Hey, so this lesson is going to introduce polymorphism. This is an important feature of C++. It's important that you understand polymorphism before you start to develop in Unreal Engine, for example, to make use of existing functionality. I feel it's also one of the more interesting C++ features, and so hopefully this will be one of the more interesting lessons. I go into the topics rather quickly in this lesson, so before we get to that, I thought I'd take a high-level introduction on why polymorphism is useful and why we have to study that. To begin, let's say we have some base class which is going to have a toString member function that will simply print out base toString. Then we also have a derived class which publicly derives from the base class. That also has a toString function which will print out derived toString. So some of the things that we'll run into includes this right here, where we have a display function, for example, and for the formal parameter that will have a base class type. In the main function, we create a base object and we pass that into display. That's going to be fine. It will behave as we may expect. But if you have a derived object and you pass that instance into the display function, you may not get the results that you may expect. Something called object slicing is going to happen, where the base class function will actually get invoked. So we have to see how we can fix that and how we can avoid object slicing in C++. Next, we can also see that we have an example here where we have a pointer to a base type. So this is where things get interesting. We will see that we can assign a derived class address to a base class pointer in C++. So this is perfectly legal. We can see that we allocate a new derived object on the heap and we assign the address of that to a pointer to a base object. So if you experiment with this, and as we'll see in the examples, there will be some issues. So we may not get the results that we may expect. You may actually get the type of the pointer, that version, so the base class version in this example. You may get that version of the function invoked as opposed to the object that, as you may expect. So you may expect the version of the function on the object to get invoked. Okay, the object that you have on the heap, so in this case that type here is derived. But instead we get the base class version invoked. So we can solve this issue through polymorphism and using the virtual keyword, as we can see here. So we specify the toString function as being virtual. That basically activates the polymorphism feature in C++. Polymorphism basically means multiple forms, so our function can have a different version based on the class. So we can see that the base class has one version that will print one thing out, and the derived version, the toString function in the derived class, will print something else out. And of course we want the appropriate function to get invoked based on the object that we have allocated. You can also think of this in terms of management. So I have some pointer to a base class type, and at some point in the program that might point to a base class object, but at another point in the program that might point to an object of a derived type. And again, polymorphism will allow us to invoke the appropriate function based on the object type as opposed to the pointer. At some point in program execution, we may pass a pointer to a base class type to that function where we invoke the toString function. Then in some other point in program execution, we may invoke that display function again and pass in a pointer to a derived object. Again, in which case we actually want to invoke the version of the function that relates to the type of the object that we have on the heap, as opposed to the type of the pointer, right? So basically this allows us to have a function with a pointer to a base class type, and we can invoke that function and pass in a pointer to an object of any one of the derived class types. And with that we can then invoke the appropriate function, again based on the object. So instead of having a display function with a pointer to a base class type and then another version of that function with a pointer to a derived class type, we can simply have one function with a pointer to a base class type, and we can pass in whatever pointer we have to any one of the derived class types. So that will point to an object of any one of the derived class types, and we can then invoke the appropriate function. And that is what we will discuss in this lesson, alright? So we will discuss quite a few things here. And as we'll see, this actually works with references as well, not just with pointers. So this is really useful. We can have a base class pointer that will then manage any derived class object type. You can also start to think in terms of containers. Remember that an array cannot store objects of different types. Right, you have an array of integers, an array of doubles, and so forth. But polymorphism allows us to store pointers to different types of objects, because you can have a pointer to a base class type, and then you can store pointers to derived types. And with the addresses assigned appropriately, of course we can iterate through those arrays then, and then again through polymorphism, through using virtual functions, the appropriate member functions will get invoked based on the object that the pointer is actually pointing at. So this is one of those limitations that we can work around using pointers to a base class type. And then again, we can have pointers to derive class types within an array, as we'll see in an upcoming lecture.